Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode we're going to talk about robotics arm in space. So let's dive right into it. Now this is not this is not something that we can consider a luxury. It is a must have in space. Think of it in this way. Basically space is very hard and dangerous. So think of it this way. If you have a room or a building, something like that, something faulty occurs, power fault or air conditioner, you just go outside and repair it. You can't do that easily in the case of space. On top of that, we don't have cranes, bulldozers and things of that nature in space for easy construction. So we have to have robotic arms. Now to give you a context of that, think of this way. International Space Station was built utilizing Canadarm 1. One was always permanently attached with space shuttle. So like it's supposed to come down to Earth every time you land the space shuttle. Now could we build let's say a habitat or a space station like that without using the arm? Short answer, yes, we did try that. But that time was just to go there and dock and hope you don't mess it up. But when you are trying to build something as complicated as International Space Station, it was a must have, because this allowed orbiter, basically the space shuttle, to dock properly and utilizing the arm, pull out a chunk, properly align it and then gently attach it without causing too much hiccups and all that. And this also gives a platform for astronaut to work properly, because let's say if astronaut has to work outside somewhere, not every place has a airlock, and even if it has airlock, the way to access it is generally very dangerous because they have to use a cable and attach one, detach one. In this scenario, it's everything automated. It's very simple. So it is a must have in space. IS, something as complicated as ISS cannot be done without robotic arms. On top of that, you might think, okay, that's a one-time use. No, it's very necessary even after you have built your structure, because it allows you to have reach and repair. Basically, International Space Station can be divided in two main categories. One internal skin out and the external modules. Basically, most of the things should be able to be repaired properly from inside of the space station without any hoo-ha. However, there are certain aspects like coolant loop and power modules and all that. These are external. Basically, this was done for safety reason. If it explodes or leak happens, it will leak into space rather than leaking inside, contaminating the system. So these must be replaced from outside. To make sure that it can be done easily, this robotic arm is a very useful tool. On top of that also is like, okay, if something goes wrong, what if nothing is going wrong and you are designing the spacecraft itself, so it can be repaired from inside. But even after that, you have to worry about berthing. Now if you are following the SpaceX trend, you must be familiar that Dragon capsule you always used to quote unquote berth with ISS, not dock. The last launch was docking assembly, because docking simply means utilizing your own power to dock with it. Basically, these spacecraft will go there and just wait for ISS to capture it. Now in docking, you will simply go and directly using your own thrusters align to it. Now that's a very dangerous procedure. That's why nobody is directly allowed to go and dock with it. So this arm makes it possible. Side effect, it's very slow. If you watch any video of docking or berthing, they will always be sped up to like 2x or 8x because it's ludicrously slow. So it is a necessary if you are talking about building a large habitat or maintaining something of space infrastructure. It's not a luxury, it's a necessity. So what about the physics aspect of it? Now this is one thing that you must understand thoroughly, is that even though you are in quote unquote weightless in orbit, you are not massless. Basically you still have mass. Let's say this hard drive is, let's say, 200 grams. This still would be 200 grams in space. The reason why I will not feel that this weight or something like that is simply because there is gravity that is falling. I'm in the same reference frame. Basically it's falling, I am also falling. We are both falling in the orbit. That's why it becomes quote unquote weightless. However, it does not become massless. Basically, if it hits something, it's gonna hit with the same mass and equivalent of its own mass. So that is why everything has to be done very slowly, because inertia still applies. Basically, let's say there are two spacecraft. You have one spacecraft, you have ISS, and they are quote unquote weightless, and you grab the arm and you just yanked it inside. Here's the deal. While you yanked it, you can directly dump energy into the system. No problem with that. But how are you going to stop it? It can't be stopped, because in Earth's atmosphere we have so many inherent experience, like things stop. Why it stops? There is friction. Why there is friction? Friction is because of gravity, or sometimes other things is also causing frictions. And other times also you have atmosphere that is causing drag. So things stop here automatically. Like our whole mentality is like moving things, not stopping them. But in space you have to worry about stopping them also. So the only way anybody does that properly is just slow down. Everything is done gently. This is for core reason. Like let's say this is a 10-ton progress craft, and you are like, okay, slowly, no problem. Like let's say even if some malfunction happens and docking does not occur properly, you're gonna have a minor collision. But if you yanked it, now of course the robotic arm is powerful enough, and you are both quote unquote in a weightless environment, so you will not feel it that even a single astronaut can yank it, but it will end up having a mass energy. So at that point it will be very hard to stop. That's why space collisions are so problematic. So you have to do it slowly. Like if you are moving basically Hubble Space Telescope, you have to treat it as a 30-ton object, not as a like, okay, nothing. You can orient it, that you can easily do. You can orient it, okay, let's rotate it, translate it or something, but if you push it, you are still pushing a 30-ton object. So physics is very simple. It is weightless, but it is not massless. So you have to treat things with respect. That's why berthing was so popular. That is why like Canadarm was built specifically with that long reach. So it will give enough time, like gently come down. If it was very small, they have to be like very close anyway, so might as well dock. So this arm makes it possible to do it gently. Okay, that's the physics aspect. How the heck actual robotic arm works? Like, so think of it this way, the robotic arm is way too long, so it was folded in these two places. If you directly type Canadarm large resolution image, you will clearly see these folds. Now these were one-time use. It was like folded during launch, and once it was in space, it was opened up, so it will not fold again. It was done that way. On top of that, it has joints. There are many joints into that. So it's not a compact system or a concealed system. It's not like our arm. Basically everything is inside. It's very exposed, as you can see. Everything you can easily see. Now each joint has one motor, one planetary gearbox, one encoder, and one braking system. Now of course they have backups and all that, but like this is one system of these four elements. You will have your motor, you have planetary gearbox, you have encoder and brakes. Now all the joints you have only has one axis of rotation. There is no combination here. Now combination is generally done in like say manufacturing robots and all that to keep it small, but here they are not doing that. If that's why you find basically the head of the arm looking so awkward. It's like one is here, then another here, then here is there, because every axis is getting another motor, independent separate motor. So it does have these four things, and it's very long. It's upwards of 30 meters long, and in terms of power consumption, it's only 1200 watt. Now you're like, okay, isn't that too little? Isn't that more or less a hair dryer? Yes, and that is why it's so slow. It's meant to be slow. They designed it to be slow. Now of course it can be fast forward, but you're not supposed to do that, and that's emergency. So that is why. And all the wiring, that is the most amazing part about this. All the wiring is inside the joint somehow. They figured it out. Like this is the most amazing part of the Canadian engineering. Like all the wiring goes inside it. The only time you can see the wiring that is going on is the fold joints. The fold joint was packed up for the launch mission. That is why you can see the wiring. You will, if you pay attention to the image, you will see thick cable routes for there. Of course, it also has insulation, Kevlar reinforcement and all that. So it is quite a sturdy object, and it is designed with heaters and all that. So in case it start to get too cold, they can heat it up without damaging anything. So, and at the ends of it, you either have a docking system or you have a clamp. Now the robotic arm is designed in such a way that it has clamp on both ends. Basically it's a arm with you have your palm, and this section is also palm. The reason why it is done that way is so it can move around in the ISS. ISS has multiple of these ports. These are like littered everywhere, so robotic arm can go clamping everywhere wherever they need to. So it is not limited to like, okay, front of the ISS has that. If they need repair in the backside, the clamp will move one after another directly coming around. And this is a quite complicated object, and I have provided the link down below where you can see the videos how they are actually doing it. Basically it's quite interesting, and it would be best seen in those videos. So mechanism is quite simple but complex at the same time, because braking is the most critical thing. Everything has to be done slowly, and everything has to be done very precisely. Now there are also add-ons to this system. It's not just, okay, it's an arm. Again, arm is not going to do anything. You must have something at the end of the arm. So what do they have? Like at the first time it was added was boom assembly. Now after the accident of Columbia disaster, is that when the re-entry happened in the space shuttle, the heat tile was malfunctioned and it destroyed the shuttle. So the second time it was decided they will have a boom basically attached to the Canadarm2. Benefit of that, it will give very extra reach. In that reach, they will have a sensor package that will scan the whole space shuttle's heat section. The whole of the heat shield it will inspect, and they can also mount astronaut there, so in case of a repair is needed. So this was done so they can thoroughly scan the system and be like, okay, 100% of the heat tiles are are at 100% capacity to avoid any disaster. So this was utilized for a short term when space shuttle was there. After that, Dexter was dead. Now this is the backbone of right now International Space Station maintenance, because this is the puppy that allows you to actually remove modules from XI and replace it, repair it, whatever you need to do, because this is very dexterous. That's why it's called Dexter. Now, can it replace 100% of an astronaut's need? No, but it does, like in many scenarios where you just have to replace a module. It's like just take this module out and replace it. This can take care of it. You have to do basic things, it can be done. Now again, there are talks about making another generation of it, and specifically Canadarm3 would be in Lunar Gateway, LOBG. So that will have even higher advanced version of this, because this was like a hastily put together, and it's a very good thing. It does work. Everything is about it is awesome. However, it's just not designed as a human replacement. So NASA is working to make another robot which has human hands, so it can do everything a human can. So this was my presentation on robotic arms in space. I hope you liked it, learn from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment. Leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.